Okay, with simplifying rational expressions, the first thing we need to know when we simplify rational express or not rational express, I don't know why I'm saying rational because I'm thinking I'm in the other class. The first thing we need to know when we simplify expressions is what is an expression? Destiny, I know that's what you're thinking in your head. How can I simplify expressions if I don't know what an expression is, right? Yeah, that's what I'm thinking too, right? So let's talk about what an expression is. Expressions. I'm going to give you an example of an expression. Here's one: 5x plus 3. That is an example of an expression, okay? 5x plus 3 is an example of an expression. Now, I am going to give you an example of not an expression, okay? This is called an equation. Here we go. This is 5x plus 3 equals 17. What is the difference between an expression and an equation? If you are an e-learner, feel free to chime in. What do you see that's different between an expression and an equation? Drop it in the chat, okay? Yes. If I am looking face to face, what do you see? Do you see anything different from these two? What is it? Yeah. Okay, so if I look at this, the difference here is the equation has a equal sign and the expression has no equal sign. So we know when we're talking about expressions, we're talking about, think of it as a sentence, right? But it has no period, okay? It has no place to go, all right? So this has no equal sign. That is what an expression is. It's like a math sentence with no place to go, no home, a sentence with no period, no equal sign. Now, on the contrary, if I talk about an equation what? Deliani, what does an equation have? Yeah, equation has the equal sign, okay? It has an equal sign. All right, let's look at these things called, if I talk about simplifying expressions, there's some things called terms, okay? Terms and all of that jazz, all right? And then we talk about terms that are alike and terms that are unlike. Okay, the thing that I want to tell you first is what you're thinking in your head. How can I talk about like terms and unlike terms if I don't know what a term is, right? Yeah, okay. So here's the deal, guys. Let's talk about what a term is. And I want you to just write this at the top of your paper, and I am going to pause the video. Okay, I want you to just write what a term is. So go ahead at the top of your paper, write term, okay? Now, a term can be a number. So it could be a number. A term can also be a variable. Or it can be the product of a number and a variable, okay? So when I say the product of, what am I talking about? What's product? What operation is that? Does anyone know? When I say product, the product, anybody, e-learners, the product of a number or variable. E-learners, help me out. Tell me what product means, guys. What is that, addition? If I say product, do you think addition? And you should all be shaking your head no, because yeah, Davina says multiplying. Because when I think addition, I think sum. When I think subtraction, I think difference. When I think product, multiplication. Yeah. So I'm taking a number and a variable and I'm multiplying them together. So an example, guys, of this, go ahead and put in parentheses an example. An example of this would be 3x. That's a term. I'm multiplying 3 times x, okay? An example would also be just 2 by itself. That's a term. Another example would just be r. R is by itself. So it could be a variable by itself. It could be a number by itself, or it could be the product of a variable and a number, meaning we're multiplying. Good job, guys, who threw it in the chat. Now, let's talk about terms that are alike versus terms that are not alike. Okay? Terms that are alike are terms that have the same variable. Be careful with this, guys. They have the same variable, and this is what I need you to know, with the same power. Are we all on the same page? With the same power. Okay, so what does that mean, Miss Bennett? Well, for instance, stay with me here, guys. If I had a 2r plus 3r, those would be considered like terms. So these are like terms. Now, I go to the other box. Here we go. If I say I'm under this term called unlike terms. Well, unlike terms, it would have either a different variable or it would have the same variable but different powers. So, different variable. Or same variable, different power. And when I say power, I'm going to say exponent, so you know what I'm talking about. Same variable, different exponent. Okay, so what do I mean with that? Well, look at this. I said 2r plus 3r are like terms. Those are alike. But guess what, guys? If I said 2r plus, and I'm going to change my pen so you can see the difference. If I said 3r squared, would those terms be alike? And you say what? Why? The exponent is different. Are we all on the same page? They have to have the same variable and the same exponent to be alike. Okay, so these would be considered unlike terms. These would be unlike terms. Okay? Are we all kosher on like and unlike? We know like versus unlike. Yes? E-learners, I'm wondering, come on, give me some feedback. Are we all good with like and unlike? Now, let me tell you one other thing that is like terms. We call these constants. Whenever someone says constant term, that just means a number, okay? Constants are numbers, okay? So constant terms or numbers are always like. These are always like terms. Are always like terms. Are always like terms. Are we all on the same page? And are we ready to see what that means? Let's do some examples here. When we simplify like terms, we are going to state how many they are. Is it that difficult, right? So if I look down here and I see I got a 6r plus a 10r, how many r's do I got? How many r's? 16 r's. That's it. That is simplifying like terms. I got 16 r's. Let's look at the example over here. Now let's be careful because now we're subtracting the r's. So I got to get rid of them. You are on it, Destiny. Yes. What about my e-learners? If I look at this one, I got to be careful. I'm subtracting the r's. How many do I have? And let me not forget my negative sign. I take 3 r's away from 5r or from 8 r's. How many r's? Yeah. Don't forget your negative sign, guys. I got negative, and I keep saying r's. You guys are right. K's. I got negative 5k. Thank you all for correcting Miss Bennett. Yeah, these aren't r's. These are k's. Does everyone see that? So I just state how many of the variable I have that is a like. I state how much I have that's a like. Okay, so I am going to pause the video. Let's continue on and go through the rest of the examples. Not so bad. Let me know. How are you feeling, guys? Is this not that bad at all? Example. Let's look at our second example. This example we have a mix. We got a variable. I'll do example 2 over here. So we have the variable and then we have 2 constant terms. So what am I going to do? Well, I'm just going to put my constant terms together. And then since I don't have a variable to combine it with, I just leave that by itself. So I'm going to drop down the 3n first because I don't have anything to put that with. 3n is by itself. But then I have my 2 constant terms, the 3 minus 7. So I'll just state how much I'll have left. What's 3 minus 7? Mind your negative, right? Negative 4. Yeah, 3 minus 7 is negative 4. Okay, so I'm dropping down. Now I would have a minus 4 left. Do everyone see that? Does everybody see it, e-learners? Let me know in the chat box if you understand what we're doing here. Okay, not so bad. Just stating how much we have left. Okay, I want you guys to try this next problem. Try the next problem. When you're done, type done in the chat. I don't have anything to combine my negative 6a. That minus goes with the 6a. That minus sign goes with the 6a. All right, guys. So what we're going to do is we'll bring down our negative 6a, because that is by itself. Then we're going to combine the two constant terms that are alike, the 10 and the 4. 4 plus 10 is 14. Okay? So, you guys, I think some of you ended up with negative 8a. We cannot do that because these are not alike. You cannot add or subtract unlike items. Okay? Only the like things stay together. If it's unlike, it does not stay together. Okay? Let's go to the next one, example 3. This time, what I see that's alike are my k's. So I combined the k's, the k and the 4k, and that gives me a total of 5k's. You see that? K plus 4k is 5k's. The only thing that's left is the negative 8. Okay? The negative 8. So I'm going to drop that down. Now, I'm going to give you a second to do the next example, but then we're going to go, but before we do that, I want to show you example 4, how to do that. Example 4 has both variables and it has constant terms. So we're going to combine the variables together first, the numbers and the variables. We're going to combine those like terms together first. Then we'll combine our constant terms. So if I look, I got a 6x and a 5x. Well, 6x plus 5x is 11x. So that's how many x's I have. Now look over here, my constant terms. I have a minus 4 plus 2. Okay? Negative 4 plus 2 is what, guys? Negative 2. Negative 2. Yeah. Negative 4 plus 2 is negative 2. And look at this, guys. Yes. There we go. Pay attention to your negatives, guys. But look at this. I have combined my like terms. Okay, let's do the last problems. For this first example, you should have gotten, when you combine the k's, you should have gotten 12k minus your 3, right? You're going to bring down the 3. Down here for this problem, again, combining like terms, you're going to combine the m's, you're adding, so you should have 6m. And then you should have plus 8 plus 8, which is 16. Okay, so the constant terms are like terms together, which are our numbers. And then we're going to combine like terms, just saying how many we have, right? Which are our variables. Combine like variables. Same base, same exponent.